On page 16, we're taking a look at traditional UCM problems, except now we're going to be dealing with very large celestial systems, the moon or the Earth orbiting the sun. So remember, if you have an orbital UCM system, in this case, right, the moon is orbiting the Earth, if you're trying to find the velocity, we're talking about the tangent velocity, the fact that it's the same speed, and all we need to do is use the circumference divided by the period. Now, what if they give you the period in days and the standard unit for a period is in seconds and the radius is in meters? Well, we just need to use whatever brand of unit conversion you prefer. So if it's 27.3 days and every 1 day is 24 hours and every 1 hour is 60 minutes and every 1 minute is 60 seconds, you should be able to come up with a way by multiplying 27.3 times 24 times 60 times 60 to get the total number of seconds in 27.3 days. You're going to be dealing with some very large numbers. To find the acceleration, this is the centripetal acceleration, of course. This is the non-traditional formula, or the one that just doesn't seem to make sense. There's no time in it. Rather, it's the tangent velocity squared divided by the radius. So v squared over r. So with those two, you should be able to get through page 16.